So this section deals with the ideal gas law, which the ideal gas law is PV equals nRT. So P is pressure. Now for this, your pressure must be in either kilopascals or atmospheres, so you'll have to be able to convert it. And your volume has to be in liters. So remember your kangaroos hopping down mountains drinking chocolate milk. So volume has to be in liters. Your N is the number of moles of your gas. R is called the gas law constant. So it will either be one of two different values. And it depends on what your pressure is. So if your pressure is in kilopascals, then you'll use an R value of 8.31 because it has a unit of liters kilopascals per mole Kelvin. Or if your pressure is in atmosphere, you'll use 0.0821 because its unit is liters atmospheres per mole Kelvin. Again, for temperature, it has to be in Kelvin. So T is always temperature and T must be in Kelvin. So here's an example. It says a cavern contains 45 liters of CH4, which is methane gas, at a pressure of 500 kilopascals and a temperature of 315 K. How many moles of gas does the cavern contain? So since we're looking at the equation PV equals nRT, I need to pick out what I have. So I have 45 liters. Liters means I have a volume, so I'm going to put on my chart 45 liters. It says at a pressure of 500 kilopascals, so that will be 500 kPa, and a temperature of 315 Kelvin. So that goes for my T. Now I'm missing two different variables. I'm missing N, which is the moles, and R, which is the gas law constant. But I do know what a gas law constant is because constant means it doesn't change. So since I have kilopascals, that means my ideal gas law, or my gas law constant in this case, is going to be the 8.31 because it is kilopascals liters per mole times Kelvin. So now I can plug it in my equation. PV equals nRT. So P is 500, V is 45, equal to N, which we're looking for, times R is 8.31, times T, which is 315. So when you're solving these, sometimes it's easier, or when I solve these, since I have N on the right-hand side by itself, okay, easiest thing to do is I'm going to say 500 times 45, then I divide by everything that's on the side with my variable. So I'm going to hit divide by 8.31, then divide by 315, so that I wind up with 8.59, we'll stay there, and N always comes out in moles. Now, this question asks for how many moles. Well, you might also get one that says find the grams. So in that case, I know how to go from moles to grams, right? I can take the moles times the mass. Well, it tells me I have CH4, so one of these at 12, four of these at 1, so that gives me a total mass of 16 grams. So moles times the mass will give me my grams. So I'm going to take my 8.59 times 16, and that's going to give me 137.5 grams. It also might ask you how many kilograms. Well, if you remember kangaroos hopping down mountains drinking chocolate milk, so kilo to meters, because this is where your grams are. So that's 1, 2, 3 steps, right? Ooh, I went backwards. So I'm starting here and I'm going this way. So I'm going that way 3 steps. So 1, 2, 3. So that would be 0.1375 kilograms as my final answer. Okay, another problem. Pause it, write it down if you need to. It says a child's lungs contain 2.20 liters at 37 degrees Celsius. Find the grams of air at 102 kilopascals. So, and it's saying the mass of air is about 29 grams is about the mass of air, since air contains oxygen, nitrogen, argon, and a whole bunch of other gases. So pick out what you know. So I have 2.20 liters. Liters means I have a volume at 37 degrees Celsius. That's a temperature. And, sorry, it moved. And 102 kilopascals. So now, first thing I need to do, since my temperature is in Celsius, I need to convert it to Kelvin. So all I have to do is add 273. And so 37 plus 273, let me do plus instead of multiply, don't make my mistakes. And that gives me 310 Kelvin as my temperature. And my N value is what we're looking for. And R is going to be the 8.31 because I have kilopascals. And so again, I'm going to have PV equals nRT. So P is 102 times V, which is 2.2, equals to N times R, which is 8.31, times T, which is 310. So 102 times 2.2 divided by 8.31, then divided by 310. So I get N is 0.087, and my units would be moles. Okay. All right, so the ideal gas law, there's no such thing as an ideal gas law. Okay, as an ideal gas, that it is just a created problem that is made to be able to work with gases. So they're saying if a gas is an ideal gas, then it follows these parameters. Well, that doesn't really happen. So make sure you look at the PDF of the notes. It explains a few more things, but hope you have a great day.